Here we want to rank 0 and the values of the derivatives of this function g at 0, 1, 2, and 3 from lowest to highest. Let's start with the idea that, remember, derivative means slope. So the derivative of g prime of 0 is the slope at 0. So we have a slope here, we have the slope at 1, we have the slope at 2, and we have the slope at 3. We need to rank these slopes from lowest to biggest along with 0. Let's start with the smallest possible slope, which is probably one that's negative. These three slopes are positive, so because they're increasing, but this slope is negative because the function is decreasing there. So the bottom of the totem pole is g prime of 2. Is there any other negative slope? No, these slopes are all positive. So we know that 0 must be the one that separates g prime of 2 from the other derivative. So 0 is next. Now we have to rank the positive slopes. A slope that is kind of shallow like this is a smaller slope, while this is a moderate slope, and this is a very steep slope. And we can assign these to these functions here, or these values here. So here we have what looks to be the shallow slope. So this is kind of shallow and therefore kind of small. The next means the next slope will be g prime of 1. Between the slope at 3 and the slope at 0, it looks as though the slope at 0 is a bit steeper, kind of like this guy. So the slope at 3, which is not quite as steep, is the next in line. So we have g prime of 3 here. And that means, last but not least, but g prime of 0, the steepest slope of them all, which is the largest. And this is the ranking we're looking for.